I am Kinson.
And I'm Peter Dobbs. We express no conflict of interest beyond our respective employments. In this talk, we introduce DICOM and discuss examples of how it can be used from the perspective of an aspiring clinical data informaticist.
Hey, Peter. I hear that you and some of your colleagues are interested in learning about medical images.
That's right. We have some experience in data analysis and are interested in clinical informatics. Can you help us understand the complexity of medical images?
Certainly, but first, tell me about what you have done so far.
Sure thing. I've looked into denoising algorithms on common images like this one of my parents' dog Laszlo, and I've tried some object detection and found that a computer can't really tell Laszlo from a hot dog without being told. And that requires labels. Luckily, dogs are cute and easily recognizable to people, so it isn't too hard to get help labeling a set of dogs and hot dogs. But that's not the same for medical images. Medical images aren't as cute as Laszlo, in my opinion. We can do the same transformations and analysis as on common images, but labeling is a lot harder. A layperson likely doesn't recognize what is captured by any of these examples.
That's right. But medical imaging data is more than just the picture itself. To make sense out of the image, you need to know the patient context, like the age or the gender, the procedure that used to capture the images, such as a CT brain with contrast, and the relevant body part, like the mole on the left upper arm. There are many more relevant metadata needed in order to understand the context and the specific for each image. This is where DICOM becomes essential. Have you heard of DICOM, Peter?
It's some sort of format for medical imaging, right?
That's right, and more. First, it's an acronym for Digital Imaging and Communications in Medicine. It specifies the format that is used for capturing medical images. As mentioned earlier, there are lots of contextual information as well as content-specific data that needs to be captured. Medical images can be captured in the schedule workflow, such as those in radiology, or as part of the patient encounter, such as in dermatology. In both cases, they are standard-based workflow that produces DICOM objects. And these objects are embedded with a very rich set of metadata, such as the patient context, the procedure information. This additional data, along with the pixel information, such as rows and columns, are represented in the DICOM header, which can prove very powerful and useful for labeling. In addition to just being the format, DICOM also defines how to transmit these objects between systems. Is one of your examples. And here are some contextual data that shows about like the study or the series. Here are some acquisition-specific metadata about these MR images, as well as here are some specific pixel data.
Whoa, cool. That could be really useful for analytics. So now that I'm more informed about DICOM, I have some thoughts and I have some questions. Here is a common path for an AI project. First, I acquire the data, then I clean and normalize them as best I can. After that, I can run some algorithms to analyze the data. With the output from those algorithms, I need to interpret the results. And if the result is interesting, I would like to distribute the results to other systems. So let's start at the beginning. How do I acquire these images?
So if you're analyzing data from a live system, then most likely you're going to get these DICOM objects from the PACS, or Picture Archiving and Communication System, or the VNA, or Vendor Neutral Archive. You can get these objects via the traditional DICOM DMC services. I see that you are the cool internet generation. Then you'll definitely be interested in using DICOM Web, which is the next generation of DICOM that use familiar web technologies like HTTP, JSON, XML, if your PACS or VNA support it.
Ah, okay. Sounds like .com Web is where I want to go. So now that I have access to data, could you tell me some key indicators within the DICOM metadata that I should look out for?
Definitely. So here are some common contextual attributes in the DICOM header that are useful for AI analysis. Like, so here you see some patient study relevant information. And here are some common pixel data attributes that tells you how to interpret the pixel data.
So Kinson, are there any standard methods to clean or normalize DICOM?
That is actually a very broad topic. Here are a few things to get started. since you may be getting DICOM objects from multiple sources, they often have different ways to capture procedure and body part information. So first thing you may need to do is to normalize these contextual values. Then you may want to extract the pixel data out of the JPEG and then perform some image transformation or feature extraction using your favorite algorithm. Note that DICOM support multiple image formats, so you have to take that into account. Furthermore, you'll want to extract the reference metadata from the DICOM header for your analysis.
And then I can run my favorite algorithm. Now, say I obtain some groundbreaking results. What should I do?
Definitely not hide them in the closet. Interpretation and distribution of results are very important, especially you want to make sure the results are consumable by the radiologist or other users as seamless as possible. This is a very large topic by itself, and there are other CDI series that cover this, so stay tuned definitely. With this said, IHE, or Integrating the Healthcare Enterprise, publishes some standard-based integration profiles that you may be interested. To get started, for capturing the AI results, you can take a look at the AI results profile. For distributing AI results, you can look at the AI workflow for imaging profile.
For sure. That's actually really cool that IHE has that all profiled. So now that I have a starting point for my analytics workflow, I think I'm ready to go. But is there anything else that I should watch out for?
There are a few things that you need to watch out for. For example, PHI or personal health information. Make sure if you're not dealing with the identified data, then you follow all the necessary regulation requirements. Sometimes there are burned-in annotation directly on the images as well that you need to extract, but it becomes less and less common nowadays and replaced by things like GSPS objects, which is another DICOM object. There are other DICOM details that we haven't had time to talk about yet, such as single frame versus multi-frame images. Last but not least, for AI analysis, you may have other reference data other than DICOM objects that you need to take into consideration. For example, diagnostic report, which may be free text or in structured format. Here are some resources that you may find useful as well.
Oh, that's wonderful. I can hardly wait to get to work.
Cool. So tell me, what have you learned today?
All right. So what I've learned is DICOM is a standard format for medical image storage and transmission. And in addition to the pixel data, it includes loads of metadata that can be useful for a plethora of analytics use cases.
You've got it. So keep an eye on other resources and course in CDI series as well as in the SIIM resource website.